Hi all. In our SQL Server covered index part 1 video, we have gone through how SQL Server covered index works and how it will use the columns that we have in our index and the predicate, seek predicate. Now we will see the statistics and as well as other solutions to improve the performance, other alternative solutions. The solution that we covered is by removing the is null function to that carrier tracking number. So before that, just I will show you the input output statistics. So for this query, so in the message you can see our input output statistics. Here the scan count is 1, logical reads are 30 and physical reads 0, and the execution plan is uses only modified data as a seek predicate. Now I will remove, this is our first solution by removing the null operator, null function, and again I am executing the same query. So in this query, as we discussed, it uses seek predicate for all these 3 columns and see the statistics. So if you see the statistics, the logical reads count is 3. Nothing but as it uses effectively the 3 columns in filtering out the data, it reads a very less number of records. Nothing but the set. In the first our operation, the data is filtered based on the modified date. Later again other 2 carrier tag number and product ID will be included. So here as the steps are increased, the logical rates were increased. So in our next step, the searchable columns, all 3 were included in the seek predicate as a searchable. So that's why these 3 act as a single set and filter the data. So if you see the modified date filters more number of records, nothing but on modified date we will have more number of duplicates. So first it will filter the data and the other duplicate criteria might be on product ID. It will duplicate the remaining data and carrier tracking number. These 3 act as a set and will filter the complete data. So that's why we are seeing less number of logical reads. Now we will go to our other solution, that is dropping the index and creating the new index by just changing the carrier tracking number and product ID order. I am copying this thing. Drop index, and so if you see our earlier index, I will show you the clear statement. It contains modified date and next carrier tracking number and next product ID. Now I am creating this index with modified date, product ID and carrier tracking number. Just I replace the product ID as well as carrier tracking number order. Okay. Now we will run our same query. The execution plan, again it uses all these 3 columns as a seek predicate, and the message count is still same. The logical reads are still same. Nothing but whatever the order that we used in the cluster non-clustered index. So the first filter criteria is a product modified date. So it contains more number of duplicates. Nothing but our table has more number of duplicates and modified date. So it filters some x set of data. Later that set data will be filtered on product ID, and then it will use carrier tracking number, and these 3 will be act as a single set and filter the data. So that's why irrespective of the order in our index, as indexes contain these 3 columns, it directly filter the complete data, and the scan count is very less, logical reads count. Now our other solution is just I will move the carrier tracking number to include list. So include is nothing but to these columns will be nothing but whenever you use this carrier tracking number in the select list, instead of go to the key lookup directly, it will use the column that we have in the include list in our index and directly fetch the data to the select. Again I will drop the index and create this index. See how that logical leads and execution plan will be. Again I am dropping the index and creating the index. Done. Again I am executing the same query. By seeing the execution plan, it's one error. Again the predicate contains carrier tracking number because it's not included in our actual index, but it included in the include list. But the filter criteria is goes to product ID as well as modified date. In this scenario, these two act as a set and filter the data, and instead of doing a key lookup directly, as the carrier tracking number is there in the include list, it directly collects the data from the include list and display it. So see the logical leads count. There may be small difference. The logical leads are 4 because the filtered data set is on only 2 columns instead of 3. So that's why you are seeing a very light small difference in the logical list, but it's not a very big impact. Okay, now we'll see. We'll change the order of the index. I will first move the carrier tracking number to the first. Okay, and again I will use is null carrier tracking number, then carrier tracking number. Yes, now I am executing the query. I dropped and pre-created the index. Now see the execution plan. So here there is no seek predicate, and we are seeing all these 3 columns were included in the predicate, nothing but now these 3 included as a predicate and non-searchable, means the filter criteria is the index is nowhere used in our query, and it's completely filter that it do a table scan instead of table seek. See, this is a table scan instead of table seek, index seek. It filters complete table data and provide the result. See, the logical leads are 609. So in our earlier cases, the logical leads are 3. When we include the carrier tracking number in the include list, the logical leads count is 4. But now the logical leads count is very high. It is due to the index order that we used in our carrier tracking number. But before this experiment, what we did is just we replaced modified date, product date and carrier tracking number, but there we don't see much difference because the modified date is the major filter criteria that used as the first column in the index, and based on the modified date the table data is filtered, and where we have more number of duplicates and the data is filtered from the data, it's again filtered product data and carrier tracking number. But here none of our index columns were used to filter the data. It's because the carrier tracking number is used with is-null function, means as we discussed in our first example, with the index order, I will show you the order. With this index order, earlier the first example that we observed, modified date, product date and carrier tracking number. In the first column is the modified date is included in the index, and in the base class nothing but, so based on that, for that modified date we do not have any is-null function or any other function, so directly the index was applied on the modified date. But later carrier tracking number was used in our product ID is used in our index, so the data will be filtered on these 2 columns. So that's why carrier tracking number is ignored Also it has is null. So this is the order criteria that we have based on our query. Now coming to the current criteria, this criteria, in this the first column itself carrier tracking number. So the query will try to filter the data based on the carrier tracking number. But when we go to the query, the carrier tracking number was applied with is null function. So with that, as the carrier tracking number is applied with the is null function, even we use the carrier tracking number in our index, as the first priority is going to the carrier tracking number, it can't use the index, nothing but it can't the algorithm can't use the non-cluster index that we created on the carrier tracking number, modified date and product ID. So first, per algorithm, it directly verify the carrier tracking number, whether we can filter the data based on this carrier tracking number that we have in the index. So it's verified that as we have is null function on carrier tracking number, it can't use this index, nothing but index C. It can't go with the index C on this carrier tracking number. So automatically it will ignore the other columns in the index, that those are modified date and product ID. So that's why we are seeing these three columns in the predicate instead of index C, and the complete table execution plan goes to index scan instead of index C. So this is the importance of ordering index in our index creation. So suppose even if you move the product ID to the first, the index will work effectively, because the product ID is in index C instead of in predicate. So this is order criteria. So nothing but what we observed is we verified the index and modified date, product ID and carrier tracking number is the first scenario, and the other scenario is modified date, product ID in index and included carrier tracking number in include list is the other scenario, and changing the order of the columns between carrier tracking number and product ID as well as modified date and product ID. So in our first scenario, nothing but the first index, see modified date, carrier tracking number, product ID. So that's why it can't use product ID and carrier tracking number in the index C. So in our first case, these two directly go to the predicate, and the only modified date is in index C. As the system can't use carrier tracking number in the index C, it will ignore the later column that we have in our index. So this is the importance and importance of order of columns in our index. And we'll see the other combination that we haven't verified. The order of the index is first product ID, and next carrier tracking, modified date, and next carrier tracking number. This we haven't verified. Now we'll do this. I'm changing the index. Now again I'm running the same query. So here, before going to the result, we'll see based on this the carrier tracking number will go to the predicate, and modified date, product ID will be as index C. Okay, nothing but these two will be used in the index. As the first column is product ID, the table data will be filtered on product ID and modified date. These two act as a set and filter the data, and it will ignore the carrier tracking number. We'll see the execution plan and the logical leads. The execution plan, index C again. So in the predicate we are seeing carrier tracking number as the only column, as it is the last in our index order, and the C predicate contains both product ID as well as modified date. And coming to the logical leads, means to get the index, to use the index efficiently in our query, we need to see how the index columns were ordered in our index create index syntax, as well as the functions that are applied on this on our query. So it's all the index seek and predicate and searchable, non-searchable, how we are seeing in our execution plan, and how we return the query and order of columns in our index. Thank you.